We are live now, so you guys be on your best behavior here. We are capturing everything. What we're going to be looking at is a real simple model I've done, a real simple corridor, kind of mimicking some of the assemblies and sub-assemblies that were done on the Route 1 corridor project that San Jose is working on. I've been helping those guys out a lot, and unfortunately there's been a lot of lessons learned. And my goal with this today is to kind of capture some of these lessons that we've kind of figured out. I want to start off and point out I am making a new class handout. Let me pull this, see if I can fit this on this monitor. All right, and the class number is, did I get the right one here? Yeah, C3D 435. I'm doing Civil 3D corridors and making one called Complex, and there's already a simple corridor document, but this thing's actually going to be available through the forum web page here, and just kind of show you where this is. Everything I'm working on stays in the shared documents folder here, and it's under Civil 3D Training, and we'll see now that there is a complex corridor class, and hopefully it'll get there. And so there's the handout that I'm working on. So I have updated it yesterday. Not a whole lot of content to it yet, other than the first little section here. I'm really going through kind of coming up with a chapter 1 on planning your corridor model, because we've learned a lot of stuff working on this Route 1 project where we'd get to a point and all of a sudden it's like, oh crud, it doesn't do what we thought it was going to do. We need to go back and change things. So I'm trying to kind of document all the issues that we came up with and what you need to ask at the beginning of the job on what you're going to do. And right now this is more outline, and some of this I'm going to fill in as we work through. Corridor, I'm kind of put in definitions here, what a simple and a complex corridors are. Do you want one baseline or multiple baselines? And I talk about pros and cons of that. Things like multiple baselines will not show up in section views or stakeout reports. So if the way it works is if I have 2 or 3 baselines, like say a T intersection, when I sample cross sections, only the cross sections for the baseline that I've linked my sample lines to, only that baseline, or excuse me, those corridor sections are the only ones that will show up in the cross-section views. The intersecting street, any corridor elements linked to that baseline will not show up in the section view. I haven't seen it yet, but I've been told for 2011 they've fixed this in that you can draw a line anywhere in 2011 and sample sections, and it will sample any corridor it crosses. Because what they was explained to me is that for 2011, the corridors, instead of being done as sections, they're actually going to extrude them as solids, kind of like the pipe routine does. So I'll actually extrude it from section to section. I don't know if you'll see that extrusion, but based on that information, you should then be able to draw a line anywhere at any station or any value, and then any corridor element that shows up within that, you should be able to sample for a section. Okay, so hopefully that is the case. Talks about regions, and it's basically anytime I have different assemblies, I need a different region for each assembly, or different frequencies in the assemblies. And also one of the things I point out here, that regions can be used to manage a real large corridor model, that you can actually turn off regions that you're not working on, and then instead of taking 2 minutes for the corridor model to update every time you touch it, you can get it down to maybe 30 seconds. So it becomes a great productivity enhancement by doing that. Okay. Talks about assemblies, and then the issue, probably the biggest issue that came up on the Route 1 is this concept of offset assemblies. And what we found is it was a great way to have a corridor model with these various elements and still have them all show up in the cross section. Going back to what I said about multiple baselines, I couldn't have them show up in the same section. Well, we found that if we did it with these offset assemblies, they do show up in the sections, and I can sample them. Okay. However, as we worked through it and got further into this project, we found, boy, there are some shortcomings with offset assemblies. Okay. So I got one pro here. It does work well, and I'll kind of show the example I did where we have some objects that are not radial or parallel with the main baseline, how the offset actually does a real nice job of modeling it. Okay, but the assembly offsets do not appear in the view edit corridor command, and we knew that going into the Route 1 job. So what we did working on that job is they just plotted sections in the drawing, kind of like I have sitting over here, and that way they can see what's going on. Every time they change the model, their section views would update. And the only drawback to that is it does lengthen the time it takes for Civil 3D to update the corridor, update the surfaces, and then update all the sampled sections, and then update all the section views. So it just adds a little bit more complexity. Okay. Hence, we found some other issues. Feature lines cannot be used from the corridor, from the offset assembly. I can't use the feature lines to build a corridor surface. It does not see them. It only sees the feature lines from the assemblies attached directly to the main assembly object in the model. Same thing with the view and edit. If we attach sub-assemblies to the main assembly object, those will show up in the view edit command, but none of the sub-assemblies linked to assembly offsets won't. Okay, and if you're wondering what an assembly offset is, I'll show you that in a sec. All right. And then the other one that we discovered the other week is kind of how we got into this. Oh boy, there's some issues with offset assemblies, is that you cannot generate a material volume for sub-assembly shapes that are connected to the offsets as opposed to the main assembly. For some reason, it doesn't see them. It will only show you the shapes for sub-assemblies connected to the main assembly object. So it made it very tough to do volume calcs, average end area and volume calcs on our different pavement materials and concrete materials because the volume routine did not see it. Okay. Other things, stock sub-assemblies and sub-assemblies, a couple of stuff we learned. If you use the multi-link sub-assembly, or custom shape, excuse me, you can either use the multi-link sub-assembly or you can convert a polyline. And I'm kind of becoming more and more a fan of the convert polyline method because it allows you to assign unique or different code names to each link and each point on the custom subassembly that you made. Whereas if you use the multi-link, you only get one field for the code name, and it applies that code to the entire object. Well, example, I'll show you my drawing. I made just a dumb little barrier shape, but the way I drew it allows me to make the upper part of it, I could make top links, and then the rest of the other links I could make, barrier links or whatever random link, but then allows you to actually do surfaces off of these objects, and it actually works pretty well. So I'm kind of becoming more a fan for my custom shapes to use the convert polyline to subassembly. Really, main thing is start number one here. Use the stock subassemblies whenever possible. Okay, don't create a custom if there is a stock one available. And then as you go through, either if it's static, you can do it from a polyline. Other miscellaneous stuff, naming conventions, and then also talk about custom programming subassemblies in .NET. I actually have built a couple of retaining walls for the Route 1 project. I'm not sure they're using them yet. They kind of evolved out of some of the issues we had using the retaining walls that came with Civil 3D. So I thought, I can make a better wall. So I took theirs and redid them. If you'd like to install those, I have a batch routine in the QCAD Custom Subassembly 2009 folder. Run that little batch routine. It'll copy all the subassemblies, all of the catalog stuff, the help files, everything it needs to make those work. It'll copy them to your computer. If you do use them, it does need to be copied to every computer in the office that's working on the project, because if you open the drawing up on somebody else's machine and they don't have the program files for it, they're not going to see that. Okay. And there's a few other things talking about just other miscellaneous objects here. But just try to really, everything that I've seen on this job and some of the other projects I've helped with so far, I'm really trying to capture all of that information in this document here. All right, so let me minimize this and let's look at some of the pictures here so we can explain some of the terminology. Oops, got some miscellaneous garbage there. All right, so what we did is that showing up right on the screen here? Okay, this is a very simplified version of the model that they did for Route 1. Right now I've only put the wall on the one side and I haven't done daylight yet on the left side. I just mainly wanted to get one side done. I built this morning just so I'd have something to demonstrate here. But where this is done is, and I can go ahead and I'll just kind of fake one in right above it here. Just to give you an idea of what we did is I'll just make an assembly. I'll just use their default name and we'll pop it in right there. All right, so we've got the assembly. Well, what you can do then is we can come in here and we can create what's called an offset. All right, so I'll go ahead and I'll just plop one right there, and I can do another one, say add an offset, and pop one there. All right, what I can do then is start attaching my objects, and I'm not going to spend a lot of time building. I'm just going to copy. So I can say I want one of those on there, and I want one of those. We'll go ahead and say copy that one to that one there. So you can see I can start building my objects off of these offsets, and then this one here that we've built here, if we click on it, you'll see that there's a third offset over at this location. Okay, so this one is using 3 offsets. I think some of the ones that they did for Route 1, there's a couple that have 4, maybe even 5 offsets. I think there's one where they had a retaining wall and then a sound wall. Another one where they had, the offset here, the wall here, and then also a wall on the other side. So it allows us to basically, as we apply this main assembly to our baseline, and that will control the frequency of we're sampling every 50 feet radially to the baseline. But then we can use other alignments and profiles for each offset to control where these points are horizontally and where they are in terms of elevation. Okay, same thing for the retaining walls here, or for these objects out here. And then we can use what are called, we did what's called a link to marked point, that we can actually then say take this line, draw it back to, and I get a little mark point right there, and it'll draw it from here to here in the cross section as it processes each section. Okay, so hopefully that isn't too vague here. Let me get rid of this. I just wanted to kind of give you a quick heads up on how this was built. All right. In the corridor then, let me jump over actually to plan view here. So what we've got is this alignment right here. That's my baseline. And then I've got an alignment right, if I can pick it there, you can see the stationing here. I've got this alignment is my left edge of pavement or saw cut line. This alignment over here is my right edge of pavement or saw cut line, and that's what I'm going to attach these 2 offsets to. Okay, then you can see I've got this real curvy retaining wall going back here. Well, there's actually, if you look here, there's this alignment right here. There's my retaining wall alignment, and so I'm able to, through the corridor, link all these objects, all these, I must say objects, all these offsets to these different alignments in my drawing. And then I've got, for like the 2 edge of pavements, I've sampled the existing ground surface that you see here, the roadway. I've sampled those for the profile. I've then used that profile to control, to make sure that my road matches there. And then I've also done a separate, up here, I've got an alignment and profile for my retaining walls. Okay, not a great design. I just, like I said, I threw this together this morning just to demonstrate some of the concept. All right, so by having this meandering wall, let me not do that. Sorry, let me let the software, the communicator catch up. I want to look at the corridor real quick here, and I'm going to go into corridor properties. And what I've done is I've actually got 2 regions in this model. I've got one region where I built the corridor using the offsets, and then another one where I did it doing links as an alternative. And you see the difference between the 2. When you have offset assemblies, they actually show up outside the region area here, or indented on the region, and I actually have to go in and assign the alignments and profiles to each offset. So I have my baseline here is tied to my main alignment, and my main profile, and it's really, I'm not even using the profile, but I'd put it in there anyways. But I am following that alignment. And then my region 1, I'm using the offset assembly, that's the name I gave it, but that has the 3 different regions. So my offset right, I connect that to the edge of pavement right, and then I'm using the edge of pavement right off my E02 surface, and then my left is edge of pavement left to the E02 surface for the profile. And then the retaining wall, I have a retaining wall alignment on the right side, and then I also have a base profile to control what the base elevation is of the wall. Okay. For region 2, we'll look at that one a little bit. I did that one using a different method where instead of using the offset assemblies, I'm using what are the generic link to offset and elevation. And those have the ability where we can actually map and control where their ends are using alignments and profiles. So I actually use these same alignments and profiles here to control my link locations using the target functionality. All right, but we'll take a look at that in a sec. I just wanted to show this piece. I'm going to pick OK here because it wants to rebuild my model. It's out of sync. All right. So what that did for us now, so let's look at this in plan view, and what you'll see by having those separate offsets as my retaining wall goes out around this way, you'll notice now that this sample or the sample line, this link line is actually coming off the wall, so you can see how they are actually being drawn perpendicular to the retaining wall alignment, not to the center line. Okay, so that's kind of one of the neat features I've seen by doing the baselines is I actually get a much better model of the wall here. You know, I probably need to increase my frequency. All right, but it's actually got that link that's going back from this point, and it calcs it relative to this point. The problem I have found is it's drawing it radially here, and they don't quite match up, and then we get some of those zigzag contours in here. Okay. The other problem with that is when I get to some of these areas, let me see if I can find one in here where I get closer. Here we go, like right in here. I've got a problem because these are not coming radial to my main alignment. They're actually intersecting the feature lines from my wall, and what's going to happen is I'm not going to get a very good surface model there. Okay, so if I turn on, I've got surfaces of these already built. I want that one. So let me turn on contours for that for a sec here. All right, so you can see because of that, I've got some bad things going on here because of the way it triangulated. Okay, if I get into these areas here where it's a little bit better, but it's getting confused here where the links need to be, or where the triangles need to be, excuse me, because the way these links are, you know, especially right here where they're intersecting each other, that doesn't look anything like I want it to look. Okay. All right. Let me turn that back to no display here. Okay. So that's kind of pro is you can see this wall follows real nice to the wall, but where I try to tie it in back to here, there's problems. At the end of today's little session, I've come up with a fix to this also, and it has to do with the order in which I've assigned the offsets and then doing that link. I've got the link going from this one to this one because you have to do it in such an order that the mark point is placed first and the link is placed second. And you can see that by going into the assembly properties and looking at construction. It processes it in this direction here. So you can see as we come through, some reason I've put 2 mark points on here. I wasn't paying attention when I was editing, but I've got my mark point. Oh, okay, that's the one I want. I put one at the crown so I could get a break line, feature line there. So I've got that one there. I called it marked point. And then on the retaining wall, I've got this link to mark point that is going to this one called back of barrier. So why did that not say? Oh, it does say back of barrier. That's the point name is back of barrier. And then this link says go find the mark point named back of barrier, but this mark point has to occur before here. Okay, the way I fixed the radial issues I had with these lines here being radial to the wall, not to the baseline, is what I did is I changed the order I built it. I built this one first, then this one, then this one. What we need to do is build your assembly, but then add the non-radial one first, then do this one, put the mark point here, and then put the link here, and I'll change that in just a bit, and you'll see the big change in that these lines will now be radial coming up this way, and it'll give me a much better model. All right, so a couple other things about this. If I do, just to show you some of the bugs here, if I do the view edit corridor sections and I try to view one of these sections, there it is. So nothing shows up. You can't do anything with it. So that's the bugs we ran into with the offsets. The variation I did on that, just to kind of come up with a solution, is converted it to the same template, but instead of using offsets, I use what are called the generic link offset to elevation. And I'll look real quick at the tool palette here. And that's going to be under our generic links, and it's this one up here, the link offset and elevation. If you look at the help for that, you can assign an alignment to control the offset, and you can assign a profile to control the elevation. All right, and I've got these right now. You can't see them in my model because you can turn them off. So let me go into the assembly properties, and we'll see now I don't have any offsets here. It's all just done by groups. So I've made two groups, and I try to, and I'll stress it in the handout, I try to get really stringent on my naming so that way when I do target mapping, it makes sense. But you'll see I have this on the right side. The very first element, I've called it saw cut right, but this is a link offset to elevation subassembly, and I've renamed it so I know this is my saw cut line, and then I've got another one that is, I left link offset to elevation, but this is the one that goes to my retaining wall. Okay, and then same thing on the left side, I've got the offset on the left, and you'll see on all of these as I click on them, it's got this option here to omit the link, and I've got them disabled. Well, let me turn those omit link. I'm going to change them back to no. I hate when they do negative items on here. Oops, don't want them to delete. Change that to no, and where's my retaining wall, and I will change that one to no. Okay, so those will all show up. So here's the link, and link, and I just put them in. These are like 20 feet wide, 0 elevation. This one's like 10 foot wide or 5 foot wide. 10 foot wide, 0 elevation. I don't care about that because we're going to attach alignment and profiles to them. Okay, so I just wanted to show you that those are physically there, and then the same kind of deal. I've got the marked point right in here. I've got a marked point. I can't pick it because it's in. Yeah, it's not going to let me pick it there because it's under my link here. But then I've got the layout. Actually, in this case, I probably could have left the link turned on. But anyways, getting a little redundant here. But let me actually do it through properties as well. And omit link, I'm going to change those back to yes. By omitting them, they won't show up in the sections. They won't be used for surface modeling. All right, you just kind of have to remember they're there. The little point node marker will be out there. Okay, so that's how that one's put together. And then if I look at my corridor model now, and we'll see how that one's put together. And that one's all done through the targets. Okay, so let me actually look at the targets for the one we did by offsets. The one I did by offsets, the only targets I've assigned here are I need to specify surfaces for the shoulder subassembly I'm using because it needs to check whether they're in cut or fill. It's not doing anything with it, but I get a bunch of errors if I don't do that. And then I've got for the subassembly I built for doing the retaining wall, you can control it completely with profiles. I've assigned a wall height profile. Okay. Everything else is controlled here. For the one that's done by the links, if we look at the targets, again, I get my two subassemblies, but now you'll see all of those. There's my two saw cuts. I've linked those. Linked those to the right and left edge of pavement alignments. My retaining wall is right there on the right side. I've attached that to the retaining wall. And then if you come down into the profile attachments, you see I've mapped We'll go ahead and click on that. So I've mapped the profile for that surface or for that alignment to my saw cut left. And where's my retaining wall? There it is. So there's my retaining wall location. Okay. And then I've got my retaining wall height of retaining wall profile as well placed there. So slightly different, just basically it's different areas in the parameters here under corridor properties where I do the assignments. So again, here's where I do the offsets, here's where I do it through the links. Okay. What we'll see now, let me go look in the drawing in plan view. All right. And I got a gap here. This is where this side's done with the offsets. And then we come over to this side, and you'll see by doing it with the links, everything is nice and radial. But the problem with that also, as you see, is my retaining wall is not radial to itself. Everything is done radial to the alignment. So for something skinny like this, that's probably not a big deal. But if, say, this was a meandering access road, something 20 foot wide, we're kind of skewing it here. So it's not going to be the optimal model. But you can kind of see how that zigzags along and follows. And I get these nice contours here. And if we look at the surface for that one, and we'll turn that one back on. Okay, you'll see I get much better triangulation through the model here. Okay, again, I got some zigzag contours that Dion was asking about earlier. But you can see that the contours here show up a lot better. I don't have that problem here where it's intersecting this barricade and I'm getting some really bizarre things. Okay, so that worked out real nice. The other thing I have found is when you do your surfaces, and let's look at the surface tab here. All right. When I built two surfaces, I've got one using feature lines only, and then I've got this one doing that we're looking at is just the links. Okay. The feature lines work a lot better for building surfaces on these things, especially with all the walls and things like that, because it treats all these, they're parallel to the alignment, and it treats them all as break lines, so I avoid the problem where I get that zigzag issue. But we do run into problems here. In terms of triangulation, this wall doesn't do a very good job because it doesn't know. Let me see if I can get this to view in 3D here. Yeah, so here's the wall, and let me use, where's my steering wheel? Bum. Don't crash on me. There we go. I have to. There we go. So now I can pivot on that. I'm getting better at the steering wheel here. Okay. So this is the region that was done. Yeah, I'll probably get rid of that, huh? This is the region that was done using the offsets, and you can see at this area down here, this is the little barricade I have. This is where these link lines came down, and they were actually intersecting my barricade because they weren't coming down radial. So I ended up with some mess in here. Okay. The problem is that I can't use the feature lines going along this. I can't use them as break lines because I can't access them because they're in the offsets. Whereas when I come now, here's the portion that was done using the link offset and elevation to control where things are, and you'll see the barricade and everything comes out real nice. But because these points back here aren't radial to the wall, off the top of the wall, it doesn't know where to triangulate, so it's actually triangulating down to these lower points here, so it's getting a little confused here. That I can clean up fairly easily if I have the links, because this is the surface we're looking at here. So I can come in and say I want the feature line for the retaining wall. I think it's top and retaining wall back, I think is what they are. See if that helps. And I might need to do a few more to get that in. Okay, so I'm able to throw those in, and that cleaned it. But I can only do that if these are all part of assemblies connected to the main, or part of sub-assemblies connected to the main assembly. So here's what we're getting off that wall. I built another surface using only the links, or excuse me, only the feature lines. Let me switch these around here. And this is where I discovered that I can't use the feature lines. Okay, I said build feature lines for the whole model, but it only output surface on the portion of the corridor that had the link elevations to control the offset, as opposed to the ones using the offset assemblies. So those offset assemblies, none of those links were seen in the model. Okay, kind of disappointed on that. So I'm kind of leaning more and more, kind of the moral as I'm getting to here is, I think as we work on these more and more until Autodesk comes up with a better solution, we'll be using this method down here where you have a single assembly, you don't use the offsets, and then for the single assembly you use the link offset elevation subassembly to calc or set out where these offset points are. Okay, almost done here. Last thing, a couple of things I'll show is I did come up with a way to fix this area in here to where I can get these coming radial, and I said that just had to do with the sequence in which I applied these. So right now, this one is first, this one is second, this one is third. What I want to do is I want this one here to be last, so what I'm going to do is pick my assembly, right-click, and I can remove an offset, and I'm going to remove that one. Okay. By removing the offset, I've orphaned these sub-assemblies. They are no longer part of my assemblies, but it doesn't get rid of them, which is nice. So now what I'm going to do is come back in here and add an offset, and I'm just going to plop it right there. I don't care exactly where it is. And let's look at our assembly properties and construction, and what you'll see now is that new offset is at the bottom of the pile. And again, just you have to keep in mind that as it processes corridors, it does it top to bottom here. All right, so I'm going to call this one offset right, just so I can find it here. And then what I'll do is I can reassemble this fairly quickly by coming in here and say move to, and grab that object there and say move to, and I'm going to move it to that one there. And I've got my little point there, move that to right there, and put my little barrier back on. Okay, and this barrier was done as a polyline, defining a subassembly from a polyline. You can tell by color that I've made this link, and this little short link here are top surface, and then this link and the link along the bottom here are just no name, or just kind of a generic link. Didn't give them any name. And then I was also able to assign unique names to all my points here, so I can actually generate feature lines or use them for surface modeling. All right, what I've got now is I've got my marked point that I was linking this guy to, but now we know in sequence this side here goes before this side over here. So what I want to do is I actually want to take this and move it to here, and I'm going to take that and move it to, and I'm going to be right there, make sure I put it in the right spot, so I put it right there. So now when I look at my assembly, it should all be in the right order now. So we'll see on this side, we've got our lane outside super, our shoulder. That's the crown mark point I put in there. Then we have the barrier, and then we have the link going back to that back of barrier one. But if we come back and look at our wall, here's the back barrier. So coming down, this point is occurring before I get to the link, so this should work fine. All right. I do need to, let me rebuild, it's going to break. I just found, because I've changed it enough, it doesn't like what I did, so ignore my errors there. So let me go into properties here, and I need to reattach everything. So by deleting it, I have to come back in and attach it to my offsets. That's the right side. I need my right profile. Okay, and then that's fine. Let me check my targets for that region. Yeah, so I took off that guy. We have no width, and I just had the wall height profile, so that is everything. So all the assemblies I detached by deleting the offset. I had to come in and re-specify the links here. And okay. We build hopefully without any errors. There we go. And now we'll come over and look at the model, and we'll see now just by changing the sequence in which the offsets were put together, we've got my wall is still, all the objects relative to the wall are still radial or perpendicular to the wall, but then the slope line I've got back now being radial to my model. And let me see if that fixed my surface here a little bit. So let's go back and turn contours on. Yeah, so you can see I've got a much better triangulation now on the slope here because I don't have the links coming off the wall intersecting the links on the back of my barricade. So I was able to clean that up. So real nice. Let's look at a couple of the cross sections here just so you can kind of see what this model's doing here. So that's really kind of see everything. So here's my edge of pavement alignment and profiles, are lining that right up with existing. And then I've got the alignment profile controlling the wall. I got the profile setting this height, and I've got another profile controlling the height, the top of my wall, and it's not quite, bear with me as I go over here. I'm using these two profiles here, so you can see I'm making my wall higher than existing, but they build the walls that way anyways. You don't want your wall following that, and I've tried to put in where I can, flat tie-in here. We can also do profiles for the top of wall, and we'll show you those sub-assemblies I made, the retaining walls here. A couple things we did is one, the Civil 3D one we found put the key on the low side instead of the high on the deep side, so that's wrong. I put it on the wrong side. And the other thing is this point here in the Civil 3D sub-assemblies, the only thing you connect this to is a surface. So what they had to do on Route 1 is they had the profile where they wanted the existing ground to be. Then they had to bring in that as a feature line, offset it, do the create feature lines, build a surface model of the profile, and then they could attach that surface to the sub-assembly through the corridor properties. And it's just like, why go through all that? So the one I built is you can link this to a profile, or this links, this I attached to that link offset. So this is the connection point, or what they call the hook point. Then there's a profile that controls this point here. You can specify the height here, you can specify the depth here, and then the wall will actually flip if this point goes below that point. This point here, the wall will actually flip over to the other side. But I can also do profiles to control this point. So as my ground profile here is undulating up and down, I can give a constant elevation to this. And then same thing with the footing. There's a profile that controls the elevation of the footing as well. I'm not using those in this model. Today I'm just using the defaults, and then I'll show you just real quick in the catalog. Once you run that little batch install routine, we'll come in, it's in the corridor imperial catalog. Sorry, Luis, I don't have them done in metric yet. But then we have a Nolte. When you do that install, it adds this Nolte custom imperial, and then here's the two walls. And actually, if you click on these, I've actually done help documents for them and try to kind of figure out, the different components. Pretty much I cut and paste what I can out of the Civil 3D one, and then just add in what the links are called, and shows how all the links are mapped out. And then these are actually built right off the Caltrans drawing, so I've put some screen captures of that in there just to verify what those are and where I got the values for that and how they will size. So this is hopefully pretty powerful. I know one of the structural engineers happened to walk by when I was doing this, and he got all excited and said, here's Caltrans plans for these. Make sure, he wanted me to put them in so they'd come in just right. So we've got some good walls. So I've got the Type 1A wall, which is the vertical wall, and then the Type 1 wall, which has the battered, couldn't think of the word here, on the buried slope. It's got the battered wall to model that. So all right, went just a little long. Somebody said they lost video. Hopefully you guys didn't lose too much. Anybody still there? I'm going to kill the recording here.